Sorry, guys. So all you're doing right here in this lab, notice you're going to measure that out. So you're measuring this amount of baking soda, right? So what you're trying to do is you are going to neutralize this baking soda with HCl. It'd be a great lab to do in person, but it requires so much material. As you can see, I need a balance. I need So notice as you add little by little, you start neutralizing what's in there. And what pH do you think you need to get to neutralize it?
Just
What's neutral pH?
0. Oh, 7.
7. There you go. So notice the pH of baking soda will be above 7, right? And you're going to add HCl, which is going to lower your pH. And once you neutralize it, you're going to get a pH of 7. That's going to tell you when to stop adding acid. You see what's going on there, Mr. Sony? Mm-hmm. It's the calculation associated with it.
Yeah, so, okay, I know this is kind of...
Go ahead.
Is liter, that's a measurement of volume or mass?
Yeah, actually what this is, we haven't even talked about this. That one right there.
That's molarity?
That's molarity. So notice it's telling you your HCl was this molarity.
Okay.
So what you're trying to do is this is you doing the experiment, right? When you did the experiment, it took 19.3 milliliters of HCl to neutralize it. Notice you got a pH 7, correct? That's where it told you to stop. So what you're doing here is you're just converting your liters. I want to know how much moles I used. So basically it took that many moles of HCl to neutralize the baking soda.
Okay.
So once you have that, notice your baking soda, since it's 1-to-1, because notice you need one of these for every one of those, right? All you're going to do is convert this, because notice this tells you how many moles of HCl you use, so therefore, since it's 1-to-1, that means you use the same amount of moles of your baking soda. You see how they grab that number right there and put it right there? Then they just multiplied it with its molar mass. And it told you how many grams of NaCl.
Okay, and then the 84, that's the molar mass of Na.
That's the molar mass of it, yes. And then this part down here is just... It's kind of saying how well your experiment went. So you were supposed to get this, and according to your calculations, you got that. So this is just saying, well, you got a 90s. Anything in the 90s to 100, the experiment went well.
Okay.
So they're just showing you the calculations behind it all. Yeah, and I would write those numbers down, the 19.3, because that's what it's going to ask on the next piece. How are we doing, Mr. Spencer?
Pretty good. Just working on it.
Finished it already? Or?
No, that portion's...
Oh, you're doing the second one.
Yeah.
Okay. Now this one here is...
Talking about the difference in boiling point.
But is this something you actually see in real life?
Yeah.
Yeah, because obviously we don't have this issue, but if it snows, they throw this salt. Which one do you think is going to work better?
The water with it.
Yeah, so all we do is they throw it on the floor and it simply lowers the freezing point. Therefore, that snow won't freeze on the road. It'll freeze everywhere else, but not on the road, which is where we don't want it.
Yeah.
And that's what. Now, do you think you know what's happening
Yeah. I'm
to the
guessing-
water or to the molecules?
I'm guessing it's bonding with the molecules and changing their properties so it boils at, or it freezes at a lower temperature.
The only thing I wouldn't say is bonding,
Okay.
because what it's doing is kind of, you got the right idea, but it's interfering.
Okay.
It's interfering with those water molecules doing what? What do those water molecules want to do to freeze?
Like come together.
They want to come together. So what this salt is doing is kind of getting in the way of them. It'll still do it,
Yeah.
but it's going to lower that temperature.
Because it takes. Okay.
That's all that's happening. And notice one works better than the other, as you can see.
Yeah. So like in the ocean, how you can have freshwater like glaciers in the ocean, but the water is going to freeze at a lower temperature.
Yeah, because that
Because that has
salt does. Yeah, you're right. Salt doesn't like to be
Frozen.
solid, I guess, with water. So you're right. The glaciers are fresh water.